Earth, a multicolored jewel in the heavens, a haven for life. But its tranquil appearance is deceiving, not because of human conflict, but because of something the eye cannot even see. We see hints of these forces in the skies above us, an elusive earthly phenomenon seen not only today, but in the age of the dinosaurs and before. Green and red lights in the night sky, sometimes appearing as sprays of color, sometimes as undulating streamers or curtains, sometimes as a diffuse glow that can be mistaken for approaching dawn. In fact, they are named after the Roman goddess of the dawn, Aurora. It was pure serendipity that this phenomenon was given a name related to the sun, because in fact, it is related to the sun. 2,000 years ago, while Western philosophers embraced the idea that the sun was a perfect sphere of light, featureless and never changing, astronomers in China were observing and recording spots on the face of the sun, spots that appeared and disappeared, moved and changed. By the 17th century, Western astronomers had caught up with the East and had even given scientific proof that the spots were indeed part of the sun. Still, no one knew what they were or what caused them. Part of the problem was that the sun is difficult to study. It is very bright enough to cause vision damage if looked at directly. As tools and methods to observe sunspots improved, a new and related phenomenon was found: tremendous fountains of light rising from the surface near the sunspots. They were dubbed solar flares. These flares, many times the size of the Earth, were composed of superheated gases and emerged from the sun at tens to thousands of miles per second. The largest of these events ever observed occurred on September 1st, 1859. On that date, British astronomer Richard Carrington observed a large solar flare emanating from a sunspot cluster, and the flare was coming directly toward the Earth. It traveled from sun to Earth in just 18 hours, and its arrival was followed by northern auroras that were visible as far south as Havana, Cuba. Southern auroras were visible over a comparable range in that hemisphere. In the middle of the 19th century, the only electronic form of communication on Earth was telegraph, a network of above-ground wires stretching hundreds of miles. Telegraph operators knew that auroral events disrupted communications, and that those disruptions were caused by differences in atmospheric electrical potential over the miles of telegraph wires. After the flare's arrival at Earth, telegraph operators between Boston, Massachusetts, and Portland, Maine, found their communications so disrupted that they disconnected their batteries from the lines. To their surprise, they found that they were still able to communicate using only the natural electrical potential from the auroras. Today we know this flare and its effects as the Carrington event, and it scientifically established the link between sunspots and the aurora. There are invisible forces at work in the universe, forces that can only be detected scientifically. They are gravity, magnetism, and the strong and weak nuclear forces. And while all of these forces play a role in our auroral mystery, magnetism is the star of this story. The sun provides light and heat to the Earth, driving weather and ocean currents, providing energy that plants and animals need to live. But the sun emits much more than just light and heat. The sun is composed mostly of hydrogen. Because of its tremendous mass, unimaginable pressures and temperatures occur at its core, producing nuclear fusion, which converts hydrogen into helium and releases energy. That energy radiates outward to the surface and is so intense that the sun's elements are ripped apart, becoming plasma, a fluid of atomic nuclei and electrons that flow in vast currents in the sun, producing intense magnetic fields. Above the surface, a haze of plasma radiates steadily outward, forming the solar wind that reaches to the farthest boundaries of our solar system and beyond. Earth-sized masses of plasma stream along lines of magnetic force in the sun's atmosphere, forming prominences. In areas where magnetic activity is most intense, the plasma slows and cools, forming sunspots, which, while appearing dark against the sun's surface, are still brighter than any man-made light short of the flash of a nuclear explosion. At times, these intense magnetic lines of force draw together until opposite poles meet. At the moment of this magnetic reconnection, energy from the field is released and the temperature soars. A bubble of superheated plasma rises rapidly, bursting from the surface to form a flare, or in some cases, a coronal mass ejection, or CME. Most CMEs move fast enough to completely escape the sun's gravity, adding to an ever-expanding bubble of plasma surrounding our solar system. Whenever the plasma approaches the Earth, the first thing it meets is Earth's magnetic field, which is produced by the circulation of molten iron in the planet's core. The highly radioactive charged particles of plasma are captured, forming bands around the Earth called the Van Allen radiation belts. Where the Earth's magnetic field faces the sun, it is compressed by the pressure of the solar wind, while on the opposite side, it is stretched out, drawn along by the solar wind. When Earth's magnetic field is struck by a CME, it is compressed and stretched even further. Plasma flows along the magnetic lines of force until the field, strengthened by the flow of the plasma, does exactly what happened on the sun. The poles of the field draw closer together until they pinch off in a magnetic reconnection. When this happens, the released energy drives a small quantity of the plasma back towards the Earth along the magnetic lines of force. There, 50 miles up, the plasma collides with atoms of nitrogen and oxygen in the atmosphere, which then give off the characteristic green and red glow of the aurora. Please join us again next time for more amazing facts and images of our planet from Starlight Express.